Hello and welcome to the session. In this session, we are going to discuss the following question, which says that 6 cards are drawn from a well-shuffled deck of 52 cards. What is the probability that it contains 1. All queens, 2. Exactly 3 queens, 3. At least 3 queens. Probability of occurrence of any event, say A, is given by number of favorable outcomes upon total number of outcomes and if X things are to be selected from N things, then number of ways for this selection will be given by NCX, that is n factorial by x factorial into n minus x factorial. With this key idea, we shall proceed with the solution. As there are 52 cards, and 6 cards are to be drawn, then total number of possible outcomes will be 52 C6. Now we shall find the probability that it contains all queens, as it must contain all queens and there are 4 queens in all. So, 4 cards are to be selected from 4 cards and the rest 2 cards are to be selected from the remaining cards, that is 52 minus 4 equal to 48 cards. Therefore, number of favorable outcomes will be 4C4 into 48C2 by using the fundamental principle of counting, and we know that probability of occurrence of any event, say A, is given by number of favorable outcomes by total number of outcomes. Therefore, required probability is given by 4C4 into 48C2 upon 52C6, which is equal to 4 factorial by 4 factorial into 4 minus 4 factorial into 48 factorial by 2 factorial into 48 minus 2 factorial whole upon 52 factorial by 6 factorial into 52 minus 6 factorial, which is equal to 1 by 0 factorial into 48 factorial by 2 factorial into 46 factorial upon 52 factorial upon 6 factorial into 46 factorial, So we have 1 by 0 factorial is 1 into 48 factorial by 2 factorial into 46 factorial into 6 factorial into 46 factorial upon 52 factorial, which is equal to 48 factorial into 6 factorial upon 2 factorial into 52 factorial, which is given by 48 factorial into 6 factorial can be written as 6 into 5 into 4 into 3 into 2 factorial by 2 factorial into 52 factorial can be written as 52 into 51 into 50 into 49 into 48 factorial. On further simplification we get 3 into 3 upon 13 into 51 into 5 into 49, which is equal to 9 upon 162,435. Therefore, the probability that it contains all queens is given by 9 upon 162,435. Now we shall find the probability that it contains exactly 3 queens. Now, the 6 cards to be drawn must contain exactly 3 queens and 3 other cards that is 3 queens are to be selected from 4 queens and 3 other cards are to be selected from rest of the cards, that is 52 minus 4 equal to 48 cards. By using the fundamental principle of counting, number of favorable outcomes will be (4C3) into 48C3, and we know that probability of occurrence of any event, say A, is given by number of favorable outcomes divided by total number of outcomes. Therefore, the probability of exactly 3 queens is given by number of favorable outcomes, that is 4C3 into 48C3 upon total number of outcomes, that is 52C6. And we know that if x things are to be selected from n things, the number of ways to do this is given by ncx, which is equal to n factorial by x factorial into n minus x factorial. Therefore, we have 4 factorial by 3 factorial into 4 minus 3 factorial into 48 factorial by 3 factorial into 48 minus 3 factorial upon 52 factorial by 6 factorial into 52 minus 6 factorial, which is equal to 4 factorial by 3 factorial into 1 factorial into 48 factorial by 3 factorial into 45 factorial whole upon 52 factorial upon 6 factorial into 46 factorial, which is equal to 4 factorial into 48 factorial upon 3 factorial into 3 factorial into 45 factorial into 6 factorial into 46 factorial upon 52 factorial, which is equal to 4 factorial can be written as 4 into 3 factorial into 48 factorial into 6 factorial can be written as 6 into 5 into 4 into 3 factorial into 46 factorial can be written as 46 into 45 factorial divided by 3 factorial into 3 factorial into 45 factorial into 52 factorial can be written as 52 into 51 into 50 into 49 into 48 factorial, which is equal to 3 factorial gets cancelled with 3 factorial, again 3 factorial gets cancelled with 3 factorial, 48 factorial cancels with 48 factorial, 45 factorial gets cancelled with 45 factorial, 4 ones are 4, 4 13s are 52, 5 ones are 5, 5 10s are 50, 2 2s are 4 and 2 5s are 10. So we have 2 into 6 into 46 upon 13 into 51 into 5 into 49, which is equal to 552 upon 162,435. Therefore, probability of exactly 3 queens is given by 552 upon 162,435. Now we shall find the probability of getting at least 3 queens. Probability of getting at least 3 queens is equal to probability of getting 3 queens or 4 queens, which is equal to probability of getting 3 queens plus probability of getting 4 queens. We know that probability of getting exactly 3 queens is given by 552 upon 162,435, and probability of getting 4 queens is given by 9 upon 162,435. So probability of getting at least 3 queens is equal to 552 upon 162,435 plus 9 upon 162,435, which is equal to 561 upon 162,435. Therefore, probability of getting at least 3 queens is given by 561 upon 162,435. This completes our session. Hope you enjoyed this session.